So we are given a function. We are giving the actual function, so 4 over 1 plus t squared is the function, and there's a different function, g, which is the antiderivative of f of t. So first part says, find the first 4 non-zero terms in the general term for f. So I want to come up with the series for this. Now, we can do this problem by taking the derivatives, but there's a quicker way to do this problem. If you notice, this is actually in the form a over 1 minus r. So the series is actually a geometric series, but when you sum up the geometric series, you get to here. So if you recognize that, this will be much quicker. So we know a is 4, r has to be negative t squared. So f of t, written as a series, the first term is 4, and then we're just multiplying by negative t squared every single time. So the next one would be 4t squared, then it becomes a positive t to the 4th, 4t to the 6th. So these are my first 4 non-zero terms. I want the general term, so I'm going to write it like this, put a plus dot dot dot. Notice there's a 4 everywhere, so just leave the 4 in the front. Notice I have an alternating sign, so I need that negative 1 to the n. And then notice you have t squared raised to a power. So there's my general term. Okay. Part B. Find the first 4 non-zero terms in the general term for the series of g of x. G of x is just taking f of t, which is what we did up here, and just taking the antiderivative. So g of x is integrating, and I want the first 4 terms, so I'm going to just take the first 4. Minus 4t to the 6th, and I'm just going to take this antiderivative. So this gives me 4t minus 4t cubed over 3 plus 4t to the 5th over 5 minus 4t to the 7th over 7 plus dot dot dot. I'll do the general term in a minute. And we do have bounds, so no plus c. If you plug in the x, all that happens is the t becomes an x. And then when I subtract off, plugging in the 0, everything becomes zeroed out. So the only other thing I'm missing is, here's my first 4 terms. I need the general term. Again, 4 is everywhere, so that 4 needs to be there. I have an alternating, so I need that negative 1 to the n. Notice that the power on the t, or the power on the x, and the number on the bottom are the same. So 1, 3, 5, 7. That's a common sequence of numbers you'll see. So 2n plus 1, 2n plus 1. Okay, lastly, now they want you to find the interval of convergence for the series that you found in part B, which is here. So basically, this is not a geometric. We're going to do the ratio test on here. Now, if you have a different general term here, which you can actually have this 2n minus 1, 2n minus 1, but then this exponent would have to be different also. That's fine. You'll get the same answer for C. So I'm going to do my ratio test on my general term that I came up with in B. Don't forget your absolute value bars, so n plus first term. So if I plug in n plus 1 here, it's 2n plus 2, and then plus 1 gives you 2n plus 3. And then multiply by the reciprocal. Okay, so here's my setup of the ratio test. Again, let's simplify a couple things. The negative 1 will become important because you're taking the absolute value. The 4's will cancel out. Notice that the x to the 2n's will drop out. You have an x squared left on the top, and the 2n plus 1, 2n plus 3. But again, degree is same on top and bottom, so we're going to do ratio of the lead, which is 1. So your limit here is actually x squared. We know ratio test says it only converges if it's less than 1, and you do the square root and solve it exactly the same way as we've done before. So square root of x squared just leaves you with x, square root of 1 is 1, and then we can solve it. Now it does ask for interval, so check your endpoints. So let's start with x equals 1. So I'm going to plug this back into my original general term. But if I plug in 1 for x, 1 to the 2n plus 1 is always 1. So that I don't need to write. So really I have this. Okay. This is an alternating series. I do notice the limit is 0 and the numbers are going to get smaller, so I'm going to say converges by alternating series test because absolute value of numbers approaches 0. or decrease to 0, or something like that. Okay, let's do the same thing for x equals -1. So if I plug in -1 into the original, I have this. Okay, now when you plug in numbers for n, for both of these, it's going to be 3n plus 1. It is still an alternating series, and your reasoning for both endpoints will be the same. So this goes for this and this. So my interval of convergence is -1 to 1, including both endpoints.